So normal distribution is done for any continuous data. So if the data is anything to do with measurements, so like length, time, temperature, I don't know, weight, mass, anything to do with measurements will be continuous because it takes a range of answers. They are not specific. So now, if I want to distribute this data, I cannot be specific about it. So I can't say the length of a table is going to be 5 meters precisely, or like exactly 5 meters. That is not possible to be precise. So it cannot be 5 meters. A person could say it's 5 meters, 3 millimeters, 5 micrometers. You can just keep on measuring even to the tiniest particle. So therefore, it cannot be a discrete data. Discrete means specific. It has to be a continuous data. So these type of data we are going to be distributing using normal distribution. When I do normal distribution, the idea is this: we can distribute a specific data using this curve. So in a class, let's say I had 20 children and I'm trying to calculate their heights. When I calculated their height, I can put that heights into a data, but because I know they take range of values, like if I measure one person height, and then if the height was 170 meters, we know it's not going to be exactly 170. He could have been 170.5, 170.25, or 170.45. I don't know. He can be anything within this range. So therefore, we can distribute using this curve. And this is a bell-shaped curve where the curve is symmetrical on the axis. So the curve is symmetrical like that, where the mean, median, mode, they will be at the center. So median, mode, mean. All of these three will be in the center. So it divides the graph into two parts, and the area that I have shaded here talks about the probability. So the probability of an event happening is calculated using the area. So the area here says 50% on this side and 50% on that side. 50% more than the mean, 50% less than the mean. Then second information, because it's continuous data, we're going to be talking about mean and its standard deviation, because both of these are interconnected. Standard deviation is how much am I deviating, my data are deviating from the mean. So if I have an average data, so let's say the height, the average height or the mean height in a class is 170. If a person who's in the class is 160 meters, that person is 10 meters less than 160 centimeter. That person is 10 centimeter less than the average. So how much ever the total accumulated variance talks about the standard deviation. Yeah. So the standard deviation and mean are interconnected. We're going to be talking about when it comes to normal distribution with the mean and standard deviation. So example 1 is he's going to say the heights of a group of children is normally distributed with the mean of 170 and standard deviation of 5, And they can say find the probability that a person chosen height is more than 172. So what we would do, we're going to distribute the heights using normal distribution. Average is 170. Standard deviation is 5. So we would put 5 squared, because when you represent a normal distribution, we would put x and we say distribution normally, and we would put mu here. Mu is the average, and then sigma squared. Sigma is the standard deviation, so sigma squared is the variance. We put the mean here, and standard deviation squared is called the variance. We put the variance there. So here I put 5 squared because standard deviation was given. Question is asking find the probability that the height is more than 172. So h is more than 172. To calculate this, in your calculator, there is an option called normal CD. And in the normal CD, you're going to put lower, upper, and then it'll ask you for sigma, and it'll ask you for mu. Lower, you're going to put, because it's starting from 172. That's the lowest. Can it go any less than 172? No. So that's the lowest. Upper is 10,000. Sigma is 5. And mu is 170. And if you put this, you get an answer. And that answer is the probability here, which is 0.3446.